Here's problem 23. A 5 kilogram piece of lead, specific heat of 0.03 calories per gram per degree Celsius, has a temperature of 80 degrees Celsius and is added to 500 grams of water having a temperature of 20 degrees Celsius. What is the final equilibrium temperature in degrees Celsius of the system? Again, we have an isolated system. So there's no heat exchange with the environment. It's only heat exchange within the system itself. So the heat exchange of the lead plus the heat exchange of the water will add up to 0. Whatever we lose from one is going to be gained from the other. So we have the mass of the lead plus times the specific heat of lead times the change in temperature of the lead plus the mass of the water times the specific heat of water times the change in temperature of the water will equal 0. We have 5 kilograms of lead, so that would be 5,000 grams of lead if we're using a specific heat in terms per gram, times the specific heat of lead, which was given as 0.03. Then we're going to have our final temperature of the system minus our initial temperature, in this case for the lead, which is 80. Difference then will be in degrees Celsius, plus the mass of the water, 500 grams, the specific heat of water, 1, final temperature minus the initial temperature of the water, which was 20 degrees. All this should equal 0. So we're going to find the final equilibrium temperature based on this. If we divide by 500, then we'll be left with 10 over here, and 10 times 0.03 will leave us a 0.3 times T minus 80 plus T minus 20 equals 0. So I have a 0.3 T plus T is equal to 20 plus 0.3 times 80, 24. So 1.3 T equals 44, or T is equal to 44 divided by 1.3. And that is 33.85 degrees Celsius. So that's our answer. That's the final equilibrium temperature of the lead and the water, 33.85 degrees Celsius.